Okay, hi everyone, welcome back to this video. It's Cisco Packet Tracer configuring routing with the CLI. We have finally reached the important part of the networking routing. Routing allows communication between multiple logical networks when configuring routing on the command line of Packet Tracer. Similar to configuring the physical hardware, you'll find that Packet Tracer offers a GUI to configure static and RIP routing protocols. In addition to this, we'll also see how load balancing works using simulation mode, which will help you understand things better. Static routing. Static routing is the no-brainer method for configuring routing, even though it requires more work. With Packet Tracer, static routing can be configured using the GUI alone. In this method, we configure a router with a destination and a gateway to reach it. So each router in a topology should know the means to reach all destinations in the network, which requires manual work. Similarly, if a router is added or removed from the topology, all routers must be manually updated to reflect this. Static routing with GUI. Even if you do not know Cisco commands, this feature of Packet Tracer comes in handy. For this exercise, we'll be using the topology shown in the following screenshot. This network has 4 routers in a ring topology with no PCs or loopback interfaces. Because we will be using only the GUI here, configuration will be kept to a minimum. The topology can be configured by performing the following steps. 1. Click on the router icon, go to the Config tab, select an interface and configure the IP address. Make sure you select on the checkbox in this section to bring the port state up. For this example, we'll be using the following IP addresses. So R1, Ethernet port 00.192.168.10.1, fast Ethernet port 01, 192.168.20.1, router 2, fast Ethernet port 00.192.168.10.2, Ethernet port 0/1, 192.168.30.1, router 3, fast Ethernet port 00.192.168.20.2, fast Ethernet port 01, 192.168.40.1, router 4, fast Ethernet port 00.192.168.30.2, fast Ethernet port 0.1, IP address 192.168.40.2. Under the routing section, click on static. The following screenshot is displayed. The following settings will be used for configuring static routing using the GUI. The concept here is to enter all the routes that are not directly connected to a router and a gateway IP that belongs to a network that is directly connected. So we'll start here. Device network mask next hop router 1, 192.168.30.1, 255.255.255.0, 192.168.10.2, 192.168.40.0, 255.255.255.0, 192.168.20.2, router 2, 192.168.20.0, 255.255.255.0, 192.168.10.1, 192.168.40.0, 255.255.255.0, 192.168.30.2, router 3, 192.168.10.0, 255.255.255.0, 192.168.20.1, 192.168.30.0, 255.255.255.0, 192.168.40.2, router 4, 192.168.10.0, 255.255.255.0, 192.168.30.1, 192.168.20.0, 255.255.0, 192.168.40.1. Now use simple PDU to test the connectivity between all the routers. Then use the simulation mode to find the route taken by the packets. How about taking a look at the routing table? For this too, the GUI has an option. Click on the inspect icon and press I and select a router. A table containing all 4 routes will appear for each route as shown in the following screenshot. But we configured only 2 routes, so why 4? The extra 2 routes are the subnets of the directly connected links in this topology. Even though there is an alternate route to each network, only 1 route is used because this is how we have configured it. We'll learn more about having more than 1 route in the load sharing section. Static routing with CLI. The configuration and the topology will be the same in this section. We'll only see the commands required for one device. The topology can be configured by performing the following steps. 1. Assign an IP address to the interface on each router using the following commands. R1 config interface fast Ethernet 0/0. R1 config IP address 192.168.10.1, 255.255.255.0, R1 config no shutdown, R1 exit, R1 config interface fast Ethernet 0/1, R1 config if IP address 192.168.20.1, 255.255.255.0, R1 config if no shutdown, R1 config if exit. Configure static routing with the IP route command using the following syntax. R1 config IP route destination prefix destination prefix mask gateway IP. For router 1, the following commands are used. R1 config IP route 192.168.30.0, 255.255.255.0, 192.168.10.2, R1 config IP route 192.168.40.0, 255.255.255.0, 192.168.20.2. Use simple PDU to test connectivity. If you get message indicating a failure, switch to simulation mode and see which router is incorrectly configured. Dynamic routing protocols. When we learned about static routing, we found that a lot of manual configuration was involved, and a change to the topology also required manual configuration changes. Dynamic protocols work by advertising routes to each other. The configuration is the opposite of static routing. Here we enable dynamic routing on the required interfaces. The routing protocol then forms neighborship with other routers and sends them the directly connected routes and other received routes. In this way, all routers exchange updates with one another. When a topology change occurs, these updates are also sent out by the routers that learn about this loss of connectivity. Configuring RIP with GUI. Packet Tracer offers a GUI to configure a dynamic routing protocol called RIP, Routing Information Protocol. This GUI section is similar to the static routing section. It has only one text box for entering the network address of the directly connected network. You may think that the rest of the configuration is similar to the static configuration, but it isn't. Whereas in the static configuration, we entered routes of other routers. In RIP, we enter the network IP address of the router's interface. By doing this, you are enabling the routing protocol on a particular interface. To configure dynamic routing with a GUI, perform the following steps. 1. Create the same for router topology we used previously and assign the same IP address through the config tab. 2. Click on RIP now. Configuring this is very easy, with each router requiring only the network IP of its own interfaces as shown in the following screenshot. Enter the following network addresses: device RIP network R1 192.168.10.0, 192.168.20.0 route R2, 192.168.10.0, 192.168.30.0, R3, 192.168.20.0, 192.168.40.0, R4, 192.168.30.0, 192.168.40.0. Once the topology is configured, use the simple PDU to check for connectivity. Let's check for two indirectly connected routers, R1 and R4, or R2 and R3. Once the connection is successful, let's see how dynamic routing works on topology changes. Use the delete tool and remove either the link between R1 and R2 or the link between R1 and R3. Use the simulation mode and test connectivity with the simple PDU. You'll find that the packets take the alternate longer route and succeeds in reaching the destination. If you have tried step 5 of the static routing topology, the packets would have failed as we did not enter any alternative gateway to each destination network. This is the biggest advantage of using a dynamic routing protocol, the routing table. A routing table lists all of the preferred routes known to a router. It is viewable in two ways. One, using the inspect tool of Packet Tracer, and the other using the show IP route Cisco iOS command. With each way, you will see a table with lots of columns and informations. We are about to see what each of these means. Here is a sample output of a command used to show the routing table. R1 show IP route C192.168.10.0/24 is directly connected fast Ethernet 0/0 or 192.168.20.0/24 120/1 via 192.168.10.1 00:00:18 fast Ethernet 0/4/0. C 192.168.30.0/24 is directly connected fast Ethernet 0/4/1 or 192.168.40.0/24 120/1 via 192.168.30.2 00:00:08 fast Ethernet 0/4/1. The first column denotes the routing protocol. The letter C is for connected and R is for RIP. If you check the routing table and configure in static routing, you'll find the letter S. The next column is the destination network. After this comes the administrative distance AD. The first number inside the square brackets, this specifies which routing protocol takes priority. The second number in the square brackets after the slash is the metric of this route, 1 RIP. The number of hops to reach a destination is used as the metric. RIP has an AD of 120 and a static routing has 1. So if a router has two routes for the same destination network via both static routing and RIP, static routing will be used as it has a lower AD. The IP address after via is the gateway's IP, also known as the next hop IP through which the route is reached. The time clock after that is called the hold down timer. In any dynamic routing protocol, messages are sent at a certain interval, 30 seconds in RIP, each time a hello message is received, the timer is reset. If no response is received within 180 seconds, this route is removed or an alternative route is found. The final column is the outgoing interface to reach the gateway, load sharing. In this topology, we have been configuring throughout this chapter. We can find that each route has two paths to reach each destination. So how about seeing two routers use multiple paths together and load balancing the traffic across them? Load balancing with RIP. We take RIP first because we do not have to do anything specific for load balancing. If there are multiple paths to reach a network destination with the same metric, RIP automatically load balances them. We will be using an interface type known as a loopback to achieve this. A loopback is a virtual interface that behaves like a real interface and takes IP addresses. We'll use the same topology we've been using throughout this chapter and just add an extra interface on router R4. We will add a loopback interface by using the following steps. 1. Unfortunately, it isn't possible to do this with the GUI with GUI. So go to the CLI tab of R4 and enter the following commands. R4 config interface loopback 0, R4 config if IP address 192.168.100.0.255.255.255.0. Now on the same router, let's enable this interface for RIP. Go to the RIP config mode and enter the network IP of this interface. R4 config router RIP R4 router if network 192.168.100.0. That's it. Create a complex PDU that is sent every 2 seconds. Switch over to the simulation mode and you'll find that the first packet to take the R1, R2, R4 route, while the second takes the R1, R3, R4 route. You can also see which routes are load balanced by looking in the following routing table. Router show IP route R192.168.30.0/24 120/1 via 192.168.10.2 00:00:12 fast Ethernet 0/0 or 192.168.40.0/24 120/1 via 192.168.20.2 00:00:14 fast Ethernet 0/1 or 192.168.100.04/24 120/2 via 192.168.20.2 00:00:08 fast Ethernet 0/1 120 via 2 via 192.168.10.2 00:00:08 fast Ethernet 0/0. Only the RIP routes are shown here. Note that the route 192.168.100/0/24 has two gateways. This indicates that the traffic to this network is load balanced. Load balancing with static routing. Static routing requires additional configuration for a route to be load balanced. Assign IP addresses to all physical interfaces and also configure loopback interfaces as explained in the RIP section. To configure a load balanced route with static routing, perform the following steps. Go to router R2 and R3 and configure a route to R4 routers loopback interface by using the following commands. R2 config IP route 192.168.100.0 255.255.255.0 192.168.30.2 R3 config IP route 192.168.100.0 255.255.255.0 192.168.40.2. Now for R1, we have to configure two routes to reach 192.168.100.0 / 24. We need to tell the router that there are two ways to get to the R4 routers loopback. We do this by using the following commands. R1 config IP route 192.168.100.0 255.255.255.0 192.168.10.2 R1 config IP route 192.168.100.0 255.255.255.0 192.168.20.2. Use the same complex PDU to see how traffic is load balanced. After this configuration, if you look at the routing table, you'll find the network 192.168.100.0 / 24 has two routes similar to RIP. Summary. In this chapter, we saw how to configure static and dynamic routing with RIP in Cisco Packet Tracer. By now, you will understand the differences between both of them and the pros and the cons of each of them. We also saw configuring load balancing with both RIP and static routing. In the next chapter, we'll only talk about a single routing protocol called Border Gateway Protocol, BGP. Although it is also a dynamic routing protocol, it differs a great extent from other dynamic routing protocols. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing, and subscribing. Thank you.